Are we alone? This question is as old as the humankind itself. For millennia, people have turned their eyes to the stars and wondered if there are others like themselves out there. Does life, be it similar to our own or not, exist elsewhere in our solar system, our galaxy? Until 1992, when the first exoplanet was confirmed, it was uncertain whether there were any planets outside those in our own solar system. Today, we know of over 3850 planets around other stars and thousands of planet candidates. Do any one of these planets have conditions that would support life? What conditions favor the formation of terrestrial class planets in developing planetary systems? NASA can help address these questions by developing missions designed to find and characterize extrasolar planetary systems. Before we can determine if there are other planetary systems capable of supporting life, we must first find them. NASA Science pursues this goal by supporting a focused suite of ground-based observations through the Kepler mission, a now retired space-based observatory which studies the prevalence, how many there are per star, of extrasolar planets, and through the operation of TESS, Transiting Exoplanet Survey Satellite, which is performing an all-sky survey to discover transiting exoplanet ranging from Earth size to gas giants. There may never have been another intelligent, technologically advanced alien species in the entire history of the universe. Although it's true that there are an astronomical number of possibilities for intelligent, technologically advanced life forms, the huge uncertainties making it a very real possibility that the humans are the only spacefaring aliens our universe has ever known. Back in 1961, scientist named Frank Drake came up with the first equation to predict how many spacefaring civilizations there were in the universe today. He relied on a series of unknown quantities that he could make estimates for and ultimately arrive at how many technologically advanced alien species there were are present in both our galaxy and our observable universe right now. With the advances of the last 55 years, many of those quantities we once could only estimate by guesswork can now be known to an incredible degree of precision. To make such estimates, nearly everyone deploys the Drake equation, a simple formula that was cooked up by the astronomer Frank Drake in 1961. It reckons how frequently intelligent species arise by multiplying the probability that biology will appear with the likelihood that it will become smart enough to develop science and technology. Most people who wield the Drake equation simply suppose, which is to say guess, the values of its terms. For example, they might say that the chance that microbes will eventually bubble out of the primordial soup of a watery planet is between 1 and 10%. But the Oxford scientists rightly point out that we really don't know this percentage with any degree of accuracy. It could be that the probability that biology will arise in many orders of magnitude less. Similar issues apply for some of the other terms in the Drake equation. If we own up to the true extent of these uncertainties and do the requisite math, the Oxford study finds that there is at least a 53% chance that we are alone in the Milky Way galaxy and that at least 40% chance that we are alone in the visible universe. Homo sapiens could be the smartest thing going. This result, they claim, melts the Fermi paradox like the butter on a hot griddle. Maybe no one has colonized the galaxy because no one else inhabits it. While there is no arguing against the fact that many of the steps that lead to intelligent creatures have unknown and possibly very low probabilities, that situation could change soon. The discovery of microbes on one of the moons of Jupiter or Saturn, something that might happen while you still have your teeth, would strongly boost the chance of finding life elsewhere and essentially guarantee that biology is as universal as door jings in a parking garage. Frankly, exploration is seldom done well on blackboards. For 2000 years, academics argued over the possibility that a continent-sized landmass sat at the bottom of the globe. The ancient Greeks suggested that it was required by symmetry, which may have qualified as a good idea in 350 BC. A better, if less optimistic, argument could have been made in the year 1600 by noting that all of the waters of the southern Atlantic and Pacific Oceans explored to date were known to be devoid of any large polar continent. Since these two sprawling bodies of water cover 55 million square miles, whereas the landmass the size of Antarctica is 5 million square miles, the a priori chances were more than 10 to 1 against there being a continent just out of sight to the south. Obviously, this analysis would have been wrong, but it demonstrates that you don't make new discoveries by computing probabilities, only by investigating, by actually doing an experiment. In case of the Antarctica hypothesis, that meant sending ships south. We can try to reckon the odds of success in our hunts for cosmic conference. That's always worthwhile, but such exercises should not deter us from an actual search.